Hi, my name is Dai Matsuzaka, and today we're going to be working with Chapter 5.6, Complex Numbers. Now, this is possibly the most interesting and kind of out of the blue unit for a lot of folks in high school. We don't really talk about, complex numbers, but basically in the SAT context, an imaginary number is just defined as I, which is equal to the square root of a negative 1. You don't really need to know the details of what this actually means in terms of math. What kind of definition? Just take this for granted. It's just square root of negative 1, right? The value itself doesn't actually exist. So we can't actually write it down and say, oh, this is approximately 0 point something. It just doesn't exist. But because it doesn't exist, it's an imaginary number, and we give it a variable I. So the complex number is a combination of real and imaginary numbers, denoted as follows: a plus bi, ab in the reals. So what is that saying? So before we had an imaginary number, right? Imaginary number is just I, which is equal to square root of square root of negative 1. But a complex number is a combination of these things, where we take an element from the real, right? So the things that we know with, like, for example, 3, right? 3 plus, say, 2 times I, that's a complex number. So this is something you've never worked with before. We always work with something like 3 plus 2. This is well defined. It's equal to 5, right? If we were told, what is 3 plus 2i? It's just 3 plus 2i. That is the simplest form you can get. And so when we're working with complex numbers in terms of the SAT, we're just trying to find out a way to simplify so that we get this form of the complex number, a plus bi, where a, b are elements of the real. Now, here's a couple rules about computation, right? So when we have a1 plus b1 I and a2 plus b2 so these are complex numbers. What we do, well, when we do addition or subtraction, we add or subtract the real part, a1 and a2, right? Because a1 and a2 are real, right? It has nothing to do with the complex, like, imaginary number I. And then at the end, you just add or subtract the imaginary part because, like terms. So really what you're doing is exactly the same thing as you've done prior with, like, polynomials, for example. Now, if this is just for addition, I'll do the subtraction case for you up here. Oh, sorry about this. All right. Okay. We can do a1 plus b1i minus a2 minus b2i. What does it equal? Well, we just subtract a1 from a1 and a2, so we have a1 minus a2, which is equal to some c. Just call it c, and we have b1 minus b2 all multiplied by I. Let's call it c1, and let's call this c2. So what do you get? Well, you just get simply c1 plus c2i. And what is c1? Well, c1 is equal to a1 minus a2. c2 is equal to b1 minus b2. Simple as that, right? Remember that this works because the real numbers are closed under subtraction, or addition, right? You add or subtract any two elements of the reals, 3, 4, 4.5, pi. You add anything together, you're still working inside of the reals. You don't ever really escape the reals. It's a really complete system. So when we work with this, when we just add these complex numbers, well, we just take a1, a2, the real part, add it together, get a nice number, c1. What about the complex part? Well, at least the real, coefficient adds and subtracts. So you do that, and then you get c2. Then you're done. Pretty easy. Now, multiplication of complex number can be complicated a little bit more, but it's not too difficult. You've already worked with this case with the what do you call it? The polynomials, and this is the same thing, right? a1 plus b1i times a2 plus b2i. Well, you just multiply each, right? If you remember the FOIL rule, right? You're just going from the outside, inside, outside, outside, and then inside, outside, right? So you're just multiplying everything with each other. So we'll do it step by step. a1 plus b1i times a2 plus b2i. Well, multiply the first thing, a1 times a2. There you go. You get that. We multiply a1 and b2i. We get a1 times b2i. So let's just actually write this out. a1 a2 plus a1 b2i, and then now we start multiplying this guy, so we have plus b a2 b1i plus we have the last term here b1 b2i squared. Now, here's an interesting about imaginary numbers. I squared is equal to -1. Why is that? Well, what's the square of the square roots of -1? Just -1. So this I squared, this creates a negative value. So if we actually simplify what we have above here, we get this following equation right here, where you see this negative comes in. This negative used to be I squared, simplified into negative. And then this part is just, again, the like terms, right? We did that already in the last slide. Now, division of complex numbers takes the following steps. You change the denominator to a real number through multiplying with the complex conjugate, and then divide the complex number by the real number. Now, what the heck does that actually mean? Well, when we say the conjugate, we actually just mean this. Look at a2 plus b2i. The conjugate of this is simply a2 minus b2i. Because if you multiply these two things together, a2 plus b2i times a2 minus b2i, you actually just end up with a2 squared plus b2 squared. You can check this out, right? You can write it all out, but you'll realize that the complex numbers, like the a1, b2i, like here, so this entire part actually just goes to 0. It cancels out. And so you're just left with this nice and simple real number because there's no imaginary number attached to it. A squared plus b squared is just a real number. Then you're actually now dividing by a real number. You just have to calculate what the above is going to be, right? a1 plus b1i times a2 minus b2i right here, the real, the term divided by the real number, right? We know how to multiply it already. Then all you can do is just divide each part by this real number. So we can actually calculate this, and basically we're going to get some value c1 plus c2i, as we do usually, right? Then when we divide this by a2 squared plus b2 squared, right, then we're actually just dividing c1 by this value and c2 also by the same value. So we're just going to end up with another real number, d1 plus d2i. Because this d1 is c1 divided by a squared plus b squared. D2 is c2 divided by a squared plus b squared, right? So we're going to be working with complex numbers quite often. And in this case, you just kind of figure out how to make it real. Division doesn't work with complex numbers, but it does work with reals. And once you have the real numbers on the denominator, then you just go ahead and just divide each term. And that's pretty much it. Thank you for sticking with me, and I'll see you again.